So just a reminder, I'll keep saying this for the first few weeks, just to make sure everybody knows what's going on. On my phone, I'll have the lecture channel open in Discord. So I'll have that open. If you see me looking at my phone during lecture, I'm not ignoring lecture or anything. I'm just looking for people asking questions in the Discord. So if you have questions during lecture, the old-fashioned raise your hand and ask a question always works. That's perfectly fine. If, for whatever reason, you want to use the Discord, that's perfectly fine and encouraged as well. I don't know if I gave my not big, but speech about this on day one, but when we were remote only, I would stream my lectures on Twitch, and I had Twitch chat right there, and I got a lot of interaction from the class that way. I got way more than I ever did in live lectures. So I like having that open just to kind of bring back the days of Twitch chat. I have some chat open, and I can see, get some interaction from you through that. If the conversation there is too off topic, there is a lecture off topic channel as well, if you just want to talk about whatever during lecture. And I realized also during day one, I never introduced myself, so I'll do that quick. I'm Jesse. Hi. Most of you probably have seen me in 116. I believe almost all of you have. But if you transferred in after 116, or if you took the 116 with Nazarene during that one semester, or whatever the reason. My name's Jesse. I like to go by just Jesse. If you want to call me Dr. Hartloff or anything more formal, that's fine. If you're comfortable with more formality, I like to just keep it casual. We can just keep it at Jesse and leave it at that. So with that, let's start talking about 312. Any other logistical issues or questions, comments, anything before I dive into some content? Yes. There's a link at the top of the website, and this is an invite link to it. Once you click that, it'll say you want to join this channel, you're invited, and then you can hop in there. That's a link to the off-topic, I'm assuming? Ren? Yes. Which I guess I have to address it now. For Objective 3, you do have to host all of the images in the sample pages. Even if you do build your own page, you still have to host all those. And there is an important difference here that the images in the sample repo are JPEGs, which is, of course, a completely different file format than PNGs. So that's the reason for that. Plus, it makes it easier for testing. If we know which images you have to serve, those are the ones we're going to test. If you just have any random image that you're hosting for Objective 3, we don't know what to test. We got to go through all your code, look for your files, and then it just slows down grading, and then you're not going to get your grades back in a timely fashion. It's just painful for everybody involved. So for that reason, you have to host those, for those two reasons. It's Mr. Dr. Yeah, or you can call me Mr. Dr. Professor Hartloff. That's fine too. All right, let's get into it. So homework 1, we're starting to learn content with this. For these first 3 weeks, we're going to learn everything you need for homework 1. What we're going to learn today will apply to all of the objectives, but after today, you will be able to complete Objective 1 in its entirety. You'll know everything you need to know to do Objective 1. So if you're ready to hop into the homework and get started, Objective 1 is on the table as of about 50 minutes from now. You'll be able to do everything with that. You still won't be able to do the Docker setup until next week, but that's fine. If you can build your app at least, and I strongly recommend building at least one objective, finishing Objective 1, before even touching Docker. That's why the materials order this way as well. Do at least Objective 1 without Docker, just however you can, and then add Docker. You won't have to rewrite your code. You might have to change a line or two in the configuration, but you won't have to change much to add Docker to your existing server. So Objective 1 first, and then somewhere in the span of doing the next few objectives, hop over to Docker when we do those lectures and add Docker to your server and then finish up the homework. But definitely do Docker before you finish the homework because you need that for every objective. All right, so Objective 1, it's 3 GET requests, or 2 GET requests, I guess. One for the path hello, which returns our hello world. One for the path hi, which redirects to the path hello. And another response, which is going to respond with a 404 not found if there's any request that's not a valid request for your server, which is neither of the first two. And then as you add the objectives, the other 4 objectives, you'll add to that list of things that won't return a 404, of course. But anything that's not defined in the homework should, with some caveats, should return a 404. For each homework objective, there are testing procedures for that objective. You should 100% follow these testing objectives. Once you're done with the objective, what I recommend going the whole way of submitting to Autolab and then downloading your file from Autolab, unzipping it, and going through this testing procedure exactly as written, because that's what the TAs are going to do when they grade your assignment. They're going to go through this testing procedure. Aside from like some edge cases for grading decisions and stuff, this is what I give the TAs. I don't give them any secret information on how to grade your assignments. This is what they have, and I give that directly to you as well, so you know exactly what the TAs are looking for. No surprises, no punches pulled. The edge cases and other information that we discuss, myself and the TAs, is almost always when they go through this testing procedure and something doesn't go right, how much partial credit do we give? So like the partial credit decisions aren't displayed because this would be a very long document. But if you for full credit, testing procedure, go through that. If everything's fine, you're good to go. So definitely go through these testing procedures for every objective. And if you technically pass the testing procedure, but you have something wrong, we generally give you the full credit. Anyway, if I miss something in the testing procedure, that's my mistake, and you shouldn't be punished for it. All right, so let's learn how to do this stuff. So on Wednesday, it seems so bright, is it? I'm trying out projector high instead of projector low. I don't know, should we have a vote? Projector low? Projector high? Low? Okay. The only problem with low is at 10 in the morning, you might be falling asleep. But I'll respect the vote. All right, so on Wednesday, we did a quick overview of HTTP. I talked about just about everything with HTTP in a very broad sense. Now it's time to go in depth and talk about how we're actually going to implement HTTP in our servers and how you're going to write that homework code. So we're going to start with talking about this request response model. HTTP is a request response protocol. The client's going to make a request, an HTTP request. Your server is going to respond with an HTTP response. So let's talk about all of that. So there is formal documentation that strongly defines HTTP, version 1.1 in this case, and that's RFC, Request for Comments 2616. So RFCs are really how the internet is defined. These RFCs, which though they're called Request for Comments, once the community discusses and agrees upon an RFC, it becomes the standard. It becomes the protocol. RFC 2616 defines HTTP 1.1. If you ever have a question, or there's anything that's not clear in my lectures, or you have a very technical question, your answer will be in that documentation. If it's not in that documentation, then it's not defined by HTTP, and then it's just undefined behavior. But the documentation covers, I'd say, anything that you would want to know. Primarily sections 4, 5, and 6. 4, I'm like 98% sure on this. My brain's going, oh, Jesse, you might not know that for sure. But I'm pretty sure section 4 is the standard defining an HTTP message. 5 is specifically requests, and then 6 is specifically responses. So those are the 3 sections that we're concerned about in today's lecture and throughout the entire semester. We're going to use HTTP all semester. This content doesn't go away. This is like in a math class. This is like teaching you addition before going into calculus. Like you have to know the basics of HTTP to do anything in this class. So sections 4, 5, and 6 have all of your answers. If you have any complex question about this content, always go to the documentation and get your definitive answer. Even if I say something in lecture and I contradict the documentation, documentation's right. That is what HTTP is. Quick reminder, new line characters in HTTP are /r/n. This /r is a carriage return. I know I mentioned this on Wednesday, but this is something, this is one of the common mistakes students make early in the semester. I want to make sure you know this stuff. It just might happen to be in the lecture question too. /r/n, carriage return. This is from the old days of typewriters. This is a historic artifact. Carriage return is when you're typing on a typewriter and that thing is whacking the letters, hitting the ink to the paper. Carriage return is when you return that back to the beginning of the line. In our computers, it's taking the cursor and putting it backwards. Taking the cursor and putting it back to position 0 on the line. And then new line /n is putting that cursor onto the next line. For modern computers, for most of what we do, /n will do both of those. But when HTTP, when the standard was written, carriage return was still a thing. People still use typewriters. So we're kind of stuck with this in HTTP. It's how all the code out there is written. It's how the servers are written. It's how browsers are written. There's no change in it. We're stuck with this. So it's a carriage return and a new line character. In the documentation, this will be referred to as a CRLF. And I'll often call it a CRLF in lectures just because it rolls off the tongue a little better. So I'm not stumbling over /r/n/r/n, which we'll talk about later today. We'll put two of these back to back. CRLF stands for carriage return line feed. Line feed is, again, typewriter terminology. It's what we used to call new lines, carriage return line feed. So carriage return line feed, CRLF, /r/n, or sometimes I'll just call it an HTTP new line, or often I'll just say new line, and I'll assume you know that I mean this. Whenever we handle new lines in this course, that's how they're going to be represented. So when you're parsing requests, make sure you're looking for this. If you just split your lines on /n, you're going to have a lot of /r's hanging around your code or hanging around your data. And when you write your responses, make sure you have both of these. If you don't have /r/n and you're just using new line characters, the browser's likely to not know what to do. It's going to treat all of your data as one single line in most cases, depending on the browser. And everything breaks. So make sure you have that /r in there. And if you haven't, I don't know, maybe I should mention this. I don't know if you've even seen /n before, but if you haven't, that's the escaped new line character in pretty much all languages. If you do like print in just about any language, do print, and then inside your string put a bunch of /n's in there, that'll give you extra new line characters. So as opposed to saying like print your string and then print with just empty parentheses, print to do some extra new lines, you can do /n. That's the escaped new line character. And /r is the escaped carriage return character. I take that for granted. I don't think I usually mention that each semester. I assume you've seen that, but I don't know. Maybe that's a false assumption. Whatever. I talked about it. We don't have to worry about it. So let's talk about GET requests. Let's look at our first GET request. It's the same one we saw on Wednesday. But let's parse this thing. Let's pick it apart and talk about every little piece of what's going on here. So here's a GET request. It's a GET for the root path. Making a request to the server, CSE312.com. And more accurately, it's going to look exactly like this. So when you're writing your parsing code, in the slides, I'll visually change your /r/n to a new line character, just visually. But when you get this request, this is what you're actually parsing. You have these /r/n's in here, and at the end of the request, at the end of a GET request, you'll have a blank line, which will be CRLF, CRLF. It'll be two of them back to back, and that's going to signify the end of a GET request. When we talk about post requests at the end of this lecture, that's going to signify the end of the headers and the beginning of the content of the request. For GET requests, there still will be a blank line there, but it'll just be at the end of the request because there's nothing after the headers. So this is what the request will actually look like. The request line has three parts. The request type, get. If this is a get request, it's going to start with get. The path, in this case, it's the request for just slash. This is what we call the root path. It's just I don't have anything more to add to that. It's the root path. Usually this is requesting your home page, your index.html, whatever protocol you have to host your home page. This is the request for just your site. If you just type google.com, you're making a request to the root path, and the path will be just a slash. And the version, like I said on Wednesday, will always be HTTP 1.1 for this course. We don't have to worry about that version number at all. HTTP 1.1. There are other versions of HTTP and versions beyond HTTP that it's not even called HTTP anymore. We're not going to mess with those in this class. We don't need to know all that stuff for understanding the basics of how a web application works. And most of them are made to improve performance, not add features necessarily. So just not pertinent to what we're doing. If you have a request for a different path, that path is going to be different. So if somebody types, this would be a request on the right to csc312.com/lecture. If you type that into the URL, this is how you're going to get the request on the server. So you can parse that path to figure out what's being requested. So for example, in Objective 1, you have to check, is this a request for /hello, or is it a request for /hi? You do that by checking that middle value and checking what it is. Is it /hello, is it /hi, and then do something different based on that. Else, send the 404. If you have any query string or any fragment, those extra parts of the URL, they'll be part of that path. It'll all show up right there. Anything after the port number is going to be in that path. Though we're not messing with query strings or fragments in homework 1. Following the request line is any number of headers. Here I only have one header, just to keep it simple for your first example. These headers are key value pairs separated by a colon. So this is a key host or a header named host with the value cc312.com. And there's an optional space after that colon, so be aware when you're writing your parsing code that space may or may not be there. I don't think I've ever seen that space absent, but according to the RFC, it's optional. So to comply with HTTP as it's written, that space is optional, so you have to handle it whether it's there or not. So when you're handling these, look for that colon, separate the key and the value, and then trim all white space from the value. So if that space is there, you're removing it. If that space isn't there, that code just doesn't do anything when you trim the white space. So look for the colon, separate it, and remove that white space. Now I don't put it right here. I have my note somewhere in these. Why would I not put it right here? Well, I'm going to talk about it right here anyway. I put it in the post request content. I'm going to say it right here. I might say it again later. I strongly, strongly encourage you to write a general header parser right from the beginning, right from homework 1. Write code, and in fact, an entire request, handle that request line too. Write generic code that can handle all of that parsing, and then you only have to write that code one time in the entire semester. We're going to parse a lot of headers throughout the semester, so if you write your code that can parse this request line, look for a /r/n/r/n, which indicates the end of the headers, and then everything in between, loop through those and put all of your headers, ideally in a key value store, your map, your dictionary, depending on your language, objects in JavaScript, and parse all the headers and put them in a key value store with the keys of the names of the headers and the values of the headers. write that code now. I would write it right from Objective 1 of Homework 1. And then every time you need to parse headers, just call that code. Call your header parser, say, hey, header parser, give me a key value store with all the headers. And then for whatever objective you have, go to your key value store and say, give me the header of this name. And then write your specific code for that objective after that. But the more generic code you can write, the more good programming practices, writing expandable, flexible code that you can add features to. You're going to add features to this server each homework. Write that generic, expandable, reusable code one time, and then just use it throughout the whole semester. Don't rewrite header parser. You don't want to be writing header parser code when you're working on homework 4. You want to write request line parsing code on homework 4, because you got enough to worry about on homework 4. On homework 3, you got a lot to do. You don't want to be redoing homework 1 stuff. So just my advice, you're either going to follow that or you're not, but if you follow that, you're going to have a much better time later in the semester. And even later in this homework, you'll have an easier time. But I see a lot of students, like whenever they need a header, they take the entire request and they search for the header name and then try to take whatever's after it and just do really, really hacky, terrible coding practices things. And I always see it because they're always in office hours because their code doesn't work. So just write the generic reusable code now. You'll have a much easier time in this course. All right, and then response. You're going to send back a response, which is going to look like similar to this. The response is very similarly structured to the request with a few caveats, a few differences here. So we want to talk about that. So more accurately like this. Same format, except after that CRLF, you're going to have the actual content of the request. So that CRLF, that blank line, isn't the end of the response. It's to separate your headers from the content. So if you're parsing headers, you look for this right here, and everything before that and after the first CRLF. So you look for the first the first CRLF right here. That's the header line. And then that blank line, everything in between is headers. And you can throw that in your header parsing code. Everything after this is going to be the body, and you can handle that however you want. For writing a response, you have to write it in this format. Make sure you remember your /Rs. That's in headers, requests and responses. So the response is going to be very similarly structured to the request with a few differences. The response line, a little bit different structure. The HTTP version comes first, followed by a response code or status code, which is going to tell the browser how things went. 200 means everything went great. Here's your content. And then followed by a human-readable message, which is a human-readable version of what that response code means. 200 means OK, so we just put OK there. The response codes are meant to be human-readable, so they aren't read by the machines at all. It's not read by the browser. The browser doesn't even care, doesn't do anything with these except display them to the human beings using them. That's it. This message can contain spaces. So like for a 404, it's 404 not found with a space in between. Since it is human readable, humans like to read spaces. So why not? Why not allow it? So when the browser's parsing these, it'll look for the first 2 spaces. Then everything after the second space is going to be the reason message or response phrase or reason phrase, status message. I usually call it a response message. All used interchangeably. The headers, you have to have 2 required headers in your response. Content type and content length. We'll talk about content length quite a bit this semester. Content type and content length. The content type tells the browser what type of content, I guess, how it should parse and reason about this content. For this, I'm just sending plain text. So text/plain is going to tell the browser that, hey, my response is just some plain text. For Objective 1, this is all you need. You can just send your hello message and your 404 message as plain text. If you want to use HTML for your 404, that's fine too. But plain text is fine if you want to do Objective 1 today. Otherwise, you have to wait till Monday's content. We'll talk about different response types, how to send your HTML, CSS, JavaScript using the content type. For now, plain text. We'll get through with plain text. Content length is the number of bytes of your content. My content here is just hello, 5 bytes. So content length 5. Making sure that all of your new lines are CRLFs, and you have that CRLF for this blank line, and then nothing after hello. That after those 5 bytes of your message, there shouldn't be anything else. So there's no new line at the end of the body here. There's nothing here. And finally, the content that you want to serve. Whatever you want to send. I'm just saying hello in this one. It's a very simple, boring message. Very boring response from a server. But that's where all the content goes that you want to send. The response codes, I showed a couple at the very end of last lecture. You're probably familiar with some of these anyway. But these come in different categories. 200 level, anything that starts with a 2. This means everything went great. Everything's fine. Nothing is ruined here. Here's your content. 300 level means you requested content that doesn't live at that URL anymore. Go somewhere else to get the content that you're looking for. 400 level means the client did something wrong. These are your 404s, which I'm sure everybody's seen just using the internet. Your 404 not found. Your 403 forbidden. You're not allowed to access that. Anything where you made a request that either there's nothing there for you or you're not allowed to access, things like that. 400 means you did something wrong in your browser, or most likely you clicked a link and that link was not appropriate or something. Somebody sent you a link that didn't have the content you want. And then 500 level codes, these are the things of nightmares. 500 level codes means the server did something wrong. This is what, as web developers, this will make you stay up at night. You'll lose sleep over these things. You might get phone calls at 2 in the morning saying, hey, things are broken, fix it. And then you got to fix stuff real quick. 500 errors are scary because this means that we messed up. Whatever code we wrote, something broke. There's some edge case that we didn't handle, or just something went down completely. Something's broken, and we have to fix it. So 404. So to go through, we got the 2 that we need for Objective 1, 404, and 301. So 404, content not found. When you send a content not found response, or just not found, but in general 404, when you send a 404, why didn't that highlight? I think these rectangles sometimes go in the foreground. Yeah, that's what's happening. I want to highlight 404, but whatever. When you send a 404, the response is going to be formatted exactly the same way as your 200 responses. So when you send a 404, you just respond with the 404, and then with whatever message you want to tell the user to say, hey, your content's not here. This can be HTML. You can do text/HTML and then send a whole web page here. And then you'll get, whatever silly 404 page a site you visit has. You can make one of those of your own and say, hey, the content's not here, didn't find what you're looking for, or whatever. But it's formatted just like a 200. There's nothing special about a 404. You could even, nothing would break if you responded with a 200 here. But the 404 is telling the browser, hey, maybe alert the user, like if you're in the browser console, alert the users who are using the browser console that this is a 404. Usually they'll be highlighted in red. Hey, your content wasn't found. But from the user perspective, if this was a 200 OK, it would behave just the same way. Nothing is changed. But we do the 404 to let people know, hey, especially developers, hey, something broke. You could respond with a 200 OK, and then in your content say 404 not found, for example, is what I mean. The content is just whatever content you want the user to see when a 404 is triggered. So everything you know about 200 that we just talked about, same applies for 404. Just make sure your response code is right. Now you would do 404. You wouldn't do 200. I'm just saying there's no magic to a 404 response. It's just a way to communicate with people. Hey, this probably isn't what you were looking for. But here's some content. It just says this isn't what you were looking for. A 301 response is different. There is no content to a 301 response. There's no body. You still have to end in a CRLF. Just like the GET requests, you still have to end in that to signify this is the end of the response. But there doesn't have to be any content there. There shouldn't be any content there. For a 301, this is going to redirect the user to another path. It's going to say, hey, whatever you requested, we got nothing for you here, but we do have something for you over here. There is a required header for a 301, which is named location, which is where the user should make that subsequent request, that redirected request. Where should, your content's not here, but here's where you can find it. I don't have anything for you at, I didn't show the request, but I don't have anything for you at the path you requested, but I do have something for you at /new-path. I do have something for you there. Make a request for that path, then you'll be good to go. So for example, if somebody requested my old path, and I respond with a 301, they're going to make the request for old path, get the response. The response is a 301, and this 301 does mean something. The browser's going to look at the 301 and say, oh, this is a redirect. The 301, it's going to look for a location header. It's going to look for the new path, and then make a second request to that new path. And then you'll host whatever you host at your new path. That's what's going to be sent in that response. So you don't have to worry about the redirect other than just saying, here's where you're redirected to. You don't have to care that there's about to be another request coming in for new path. You just say, here's your redirect, and then forget about it. Then you get another request, and it's a request for new path, and then you handle that as a completely independent request. You should add this content length 0 begrudgingly. You don't need content type because there's no content. You shouldn't need content length because there's no content. But I've seen in Firefox and Firefox only, if you don't have content length 0, Firefox will just hang and won't trigger the redirect. I don't know why. I'm 99% sure that Firefox is in the wrong on this one. But just to avoid issues, potential issues during grading, put your content length of 0 there, and then you don't have to think about it. You don't have to worry about it. These redirects can be absolute or relative. So the previous example was relative. If we get a request and we redirect them to a partial URL or any string that's not formatted as a full URL, it's going to be a relative path. So it's going to make the request to the same protocol, host, and port as the original request, just with a new path. That's the only thing that'll change. If you put a full URL there, you can redirect people away from your site entirely. If you want to redirect them to some other site, maybe you change domain names would be a good use case here. Maybe you change your domain name, but you still want to keep the old domain name live. You would redirect the old domain name with an absolute URL over to your new domain name. So to do that, just add your full URL for that location. Start with the protocol, server, Port, if you're not using one of the standard ports, Google's going to use 443, of course, so no port needed. And then to the root path, whatever path you want. So for the homework, you just do /hello. When somebody requests /hi, redirect them to /hello as a relative path. All right, and post requests. So the good news about post requests is they're going to look almost identical to your responses, except you're going to be on the other side of things. So instead of writing these is pretty straightforward. Just make sure you remember your /r's is the big caveat. But now on the other side of things, when you're receiving post requests or any request with a body, we have to worry about parsing this. So we want to look for our CRLFs. The first one, everything before the first one is going to be the request. That same thing as the GET request. But now when we parse the headers, in your GET requests, you might be tempted to just split everything on CRLF and then have some special case to handle the last thing, which is going to be just the empty string. Just say, if no colon is found, don't handle this as a header. Otherwise, handle it as a header, parse out everything. You'll be tempted to do that. With post requests, you have to look for that blank line. You have to look for that in your string, in your parsing. So you look for this blank line. Literally search for the character /r/n/r/n. Look for that string as a substring in your request, or later on in the course as bytes, which we'll talk about for homework 2. For now, we can do string parsing. Look for that sequence, and then everything before that and after your first /r/n, those are all your headers. Parse those headers, which will include content type and content length because there's content now. And then everything after this CRLF is going to be the actual content of the request, the actual body of the post request. So you'll get content type, which tells you the type of content. To be honest with you, you probably won't have to read this header at all in this course. Everything in the homework docs will be defined. If you get a request for this method and this path, you know what type the content is going to be. And when we're testing, we're not going to trip you up and give you different types and stuff. Just not an exercise I need you to have to do in this course. I would like you reading the header, but Content length, on the other hand, this we need to think about. For homework 1, you might be able to get away without reading it. Might. I would recommend reading it anyway because in homework 2, starting with homework 2, you must read content length and you must care about that content length. If you're reading that now, you don't have to think about it as much on homework 2, though there is extra stuff on homework 2. So when you read content length, and here's my note, write your general header parsing code. So when you read content length, that's going to be the number of bytes to read after that CRLF. So if you read everything after that, and you read the content length, and the length of the content doesn't match the content length header, you know that you don't have the full request. That means you got to go back to the TCP socket and read some more bytes to be able to get the rest of the request. Now for homework 1, you might be able to get away with this. For homework 1, for all the objective 4 and 5 stuff, you might be able to get away with that. I think most browsers are going to send those requests all in one shot. You'll read them all in one shot. But if you don't read the full content length, you should be checking that content length header and making sure. So if it doesn't work for you and you're not reading that content length header, it's not going to be full credit on the homework. So you're playing with fire if you don't read that, but there's a possibility you could take a gamble if you can't figure out reading content length and reading from the TCP socket twice. You could take a gamble and try to get it. Might. Homework 2, you will not do it now. You want to do it later. If you have extra time in these first 4 weeks before homework 1's due, do it now. Do that content length. Then finally, read the body. And then after that, it's whatever feature you're supposed to be implementing. You're done with HTTP at that point. Take that content and whatever your server has to do. For objectives 4 and 5, it's talking to a database and then responding with whatever response you need to respond with. Just like GET requests. When you get a GET request, do whatever you do with that request and then send a response. Once you parse all of this, it's do whatever you do with that data that was sent in the POST request, then send a response to the user. The response to a POST request, the response to a PUT, the response to a GET, responses will always be the same format. You can respond, you can get a POST request and respond with a 404 or 301. There's nothing that changes with the response between GET, POST, PUT, delete, head, whatever. So I won't talk about responses again. Live examples, but before that, we got our lecture question. There should be no surprises on this one. I told you on, I even said on Wednesday that this would probably be the lecture question, then I spoiled it again earlier today. I really want you to know this, is the point. I really want you to know this. The first time I taught this class, I didn't talk about this very much. Like I mentioned it in lecture, and I just assumed everybody would get it. And that was like hours and hours of office hour time were spent just saying, you need your /Rs. What are you doing? You need your /Rs. So I'm making sure the TAs and myself don't have to go through that again. What? Yeah. Will the web server still read the byte length of content that the content length is, or would there be some sort of error? I'm not quite sure I understand the question. Let me think about that for a second. Does the word socket have a standalone definition in web dev? I guess a socket is, I don't know for sure, but when I hear socket, I think of a connection between two devices. So we talk about TCP sockets, which is a TCP connection where we send bytes back and forth in a stream. And we'll also talk about web sockets, where it's the same idea, but adding a little more structure on top of TCP. For the byte length question, you're going to get the request, and it's up to you to read the content length and the content and making sure that you have the right amount of data. A TCP socket connection, where you're going to use in your homeworks, when you read from that TCP connection, it's just bytes. TCP does not give a damn what the content is. It's just ones and zeros. TCP doesn't care. TCP is not going to read your content length, not going to check how much content was sent. It's just going to say, whoa, client sent you some bytes, here they are. And that's it. And if the client sends more bytes, it's going to say, here's some more bytes. Actually, that's even a little misleading. You have to ask the socket, hey, are there bytes to be read? And if there's anything on the stream that's been sent, it'll read those bytes. Everything after that is up to you. You have to do the parsing, read the content length, and make sure that you got the full request. That's all up to the code that you're going to write. Autograder is not grading, that's correct. So with day one, we had the issue where we pretty much killed Autolab. So my solution to that was just remove the autograder, and it's just recording your submissions, and then I'll run the grader later. After midnight today, I'll upload the grader. Actually, I might do it before, because people who do it outside of class, watching the video, will, yeah, exactly. Grader isn't up, so we don't crash the server. Who watch the video, they won't crash the server because they'll do them one at a time. It won't be 100 people hitting it at a single time. But I will tell you the answer right now. What's the answer, everyone? E, yeah. So hopefully this is in everybody's head. I know I went a little overboard on the /R/N this semester, but I want to make sure we never get that question in office hours. All right, so let's get into some live examples and see what this stuff kind of means, what I mean by a lot of this stuff. And I'm going to do something I've been hesitant to do in previous semesters. I'm just going to straight up say, I recommend you use Python for this course. You you have the choice of any language for the homework assignments. Most students historically have chosen Python, and then the first semester, most of the students chose Python, and then because of that, I started having more lecture examples in Python, and then because I have more lecture examples in Python, more students use Python, and it's just kind of building up to just being a Python course, basically. So I'll just recommend Python. You're still allowed to use whatever else you want. The second most popular language is Node with JavaScript. And then a few students tend to use Go. If you have experience with Go, you might like using that language. And then a few poor souls use Java. And I don't say that to pick on the language, by the way. That I realized as it came out of my mouth, that might come across wrong. But for this course specifically, Java does have some aspects that make your life more difficult, specific to this course. There are other courses where Java would make your life easier than Python or JavaScript. But like right from homework 1, first of all, setting up Docker with Java or any compiled language is more steps because you have to compile inside your Docker file, which isn't the easiest thing to set up. It's not the hardest thing either, but it's one more thing you have to worry about. And you have to parse and write JSON right from homework 1 in objectives 4 and 5. And that's not easy to do in a strongly typed language. So I didn't say that meaning to pick on Java, but you do have a few extra steps. You have to get an external JSON parsing library, a JSON library, and you also have to mess with your Docker file a lot more than you probably want to. So JavaScript and Go work fine. Python, you'll have the benefit of I'm going to have even more examples in Python in lecture than I have in the past. But I will still have some examples in other languages as well. All right, so let's take a look at how to have the basic setup of a server in Python. And for this, strongly recommended, and I hope by now you understand, when I say strongly recommended, I mean it'll save you hours of time. Import socket server and use socket server as your TCP library. This will be your TCP socket connection library. There is a library that's just socket, which you can use if you just Google TCP socket server Python. You might get documentation that uses socket. Socket server itself uses the socket library and adds extra features on top of it for you that make your life easier. So I'd recommend just using socket server and take advantage of those features. They're all allowed in this course. They don't do any HTTP stuff for you. They just handle the TCP stuff, so we don't have to think about it in the course. To run a socket server threading TCP server or just TCP server. Starting homework 3, you'll need threading in there, and I'll talk about that when time comes. .serve forever, and give it a host and a port. When I run this, I'm going to be running my server, and the server takes a TCP handler, which you have to define. This extends, if you haven't seen inheritance in Python, this is what it looks like. I'm creating a class, which I'm just naming it my TCP handler, and it extends socket server.base request handler, the base request handler class, which is defined in the socket server package. That's the class that I'm extending. And then I have to override the handle method, which doesn't take any parameters, but does access some fields of the request handler class. Oh, I don't want to do that. Let me delete some of this. I'll just comment it out because I will talk about that at some point. So when you get a request, this handle method is going to be called, and you'll have access to the fields of the request handler. The most important part of that is request. And first I'm going to call receive with some number. You can just leave this at 1024 1K right now. And, oh, shoot, it is 1051. You'll get that data and then decode it. You'll get the data as bytes, decode it so it's a string. do any parsing you need to do, and then request.sendAll. Send your response, and make sure you encode the string as bytes. TCP only speaks bytes. I'll pick up with that next lecture. I didn't realize I was out of time there. See everybody Monday. Have a great weekend.